morning, welcome to new lecture. Today I will review several examples regarding centroid, center of area. Assume we have this shape and we want to find centroid for this area. 4 feet, equation for this edge or curve y is equal to x squared over 4. I want to find centroid, so I want to find x bar and y bar. And I know x bar, I prove it, is equal to integration of x tilde dA divided by integration of dA. Let's say I will assume one small element. This element dimension in the x direction it is dx. In the y direction it is y. So the x tilde means the distance of centroid of this element in the x direction. This is x direction, this is y direction. The distance of this element in the x direction, the distance of centroid. I assume this element in the x distance, and the height of element it is dx. So the centroid for this small element, which is rectangular shape, it will be x plus dx over 2. Because dx it is differential length, it is very small, so x tilde will be equal to x. How about y tilde? Y tilde is centroid of this, again, small element in the y direction. Entire height it is y, so it will be y over 2. If I plug here, let's say I find dA as well. dA will be area for element, it will be y times dx, and because y it is x squared over 4, I will plug instead of y x squared over 4 times dx. So if I plug here, this will be integration of x squared over 4 dx divided by integration of x squared over 4 dx. What is the variation for x? X varies from 0 to 4. So x varies from 0 to 4, from 0 to 4. From here, if I integrate this, I will end up with x to the power of 4 over 16 from 0 to 4. This will be x cubed over 12 from 0 to 4. Answer will be 3 feet. In a similar way, if I find y bar will be equal to integration of y tilde dA over integration of dA. That will be equal to integration. Instead of y tilde, I can plug y over 2. Because y is x squared over 4, so this will be x squared over 8. dA, again, it is x squared over 4 dx divided by integration of dA, x squared over 4 dx. X varies from 0 to 4, from 0 to 4. So if I integrate this and I plug this number, I will end up with 6 over 5 feet. This is about this example. Let's look at the next example. Next example was a sector of one circular shape. y, x, this is alpha, this is alpha. I want to find centroid for this sector. How I will find? I will assume one element. Again, I will assume this element in the theta direction, in the angle direction. So I will assume one small element like this. This angle is d theta, and this is theta. This radius is r, so the length of this arc will be r times d theta. Now, area, differential area for that element will be area for this red triangle, which is r one side times r d theta, another side times half. It will be equal to r squared d theta over 2. Then the centroid for this triangle, it will be here, it will be respect to point O origin, it will be 2 over 3 r. Because this angle, this angle is theta, the differential, this element, if I draw it bigger, is like this. This is d theta, the radius is r, and this angle with horizontal direction, this angle is theta. So the centroid, respect to origin O, it will be 2 over 3r, because it is triangle shape. This is r. This arc, it is close to straight line, because this is d theta, very small angle. So this will be r d theta, this will be 2 over 3r. If I project in the x direction, this will be 2 over 3r cosine theta. So from here to here, the centroid location in the x direction, this is 2 over 3r. From here to here, it is 2 over 3r. If I project in the x direction, it will be 2 over 3r cosine theta. So this will be x tilde, the centroid for that small element in the x direction. So if I plug here x bar, formula integration of x tilde dA divided by integration of dA will be equal to, theta varies from negative alpha to positive alpha to positive alpha, x tilde 2 over 3 r cosine theta dA r squared over 2 d theta divided by integration of negative alpha to positive alpha r squared over 2 d theta. If I integrate, I will end up with r cubed over 3 sine theta from negative alpha to positive alpha, because these two, they will cancel out. This will be 1 over 3 r times r squared, it will be r cubed. So r cubed over 3 I can pull out of integration. So here I will integrate only cosine theta d theta. Integration of cosine theta, it will be sine theta. Here again, r squared over 2, because it is constant, I can pull out of integration. I will integrate only d theta. Integration of d theta will be theta from negative alpha to positive alpha. So it is very simple integration, because you see r cubed over 3 is constant. You will pull out of integration. Here r squared over 2. So here you will integrate only cosine theta d theta. Here only d theta. After you plug this limit, you will end up with 2 over 3 r sine alpha divided by alpha. This will be x bar. Next example. Next one, it is this shape and a h equation for this curve y is equal to h over a squared x squared. I want to find x bar for this area. Again, I will assume one small element. For example, in this direction. The thickness for this element, it is dy, and the distance from origin, it is y. The length for this element, it is x. So, x tilde, the element centroid in the x direction, will be equal to, if this is a small element, it is rectangular shape, so the x tilde will be x over 2, y tilde will be y plus dy over 2. Because dy over 2 it is very small, we can neglect that, so y tilde will be equal to y. Now, from here, this equation, I can write x is equal to a over h to the power of 1 over 2 times y to the power of 1 over 2. Let's see, everything is right. Yes, this x will be equal to a divided y over divided by h to the power of 1 over 2, and y yes, y to the power of 1 over 2. So from here, dA will be equal to x times dy. So instead of x, I can plug this. It will be a h to the power of 1 over 2 y 1 over 2 dy. Now, x bar will be equal to integration of x tilde dA divided by integration of dA. That will be equal to y varies from 0 to h, so from 0 to h, integration from 0 to h. X tilde, it is x over 2, so I will plug this term divided by 2. That will be a divided by 2h to the power of 1 over 2 y to the power of 1 over 2 times dA. I have here a h to the power of 1 over 2 y to the power of 1 over 2 dy divided by integration 0 to h a divided by h to the power of 1 over 2 y 1 over 2 dy. So if I integrate this, it will be 2a over 3h to the power of 1 over 2 y to the power of 3 over 2 from 0 to h. And if I simplify this, I can write integration from 0 to h a squared 2h y dy. So from here If I plug it and integrate it, I will end up with 3 over 8a. So x bar will be equal to 3 over 8a. Okay, let's look at to the next example. Next one is this shape. Six inch, 6 inch, 6 inch, 6 inch, x, y. Okay. I want to find centroid for this shape. I want to find x bar and y bar. How I will find? I will divide two different shape. I know the centroid. For example, this is square 1, square number 2, square number 3, and triangle number 4. Then I will take moment of area respect to the y-axis and moment of area respect to x-axis. Let's first start moment of area respect to y. So moment of area respect to y for square 1, it will be 6 times 6 times 3. 6 times 6, it will be area for that square 1 times 3, the centroid up to y, plus for square shape number 2, again it will be 6 times 6 times 3. 6 times 6 area, centroid up to y, it is 3, plus for square number 3, it will be 6 times 6 times negative 3. Area will be 6 times 6. The distance of center up to y, it will be negative 3. Plus, for that triangle, 6 times 6 times half will be area for this triangle shape. The centroid up to y, the distance of center up to y, it will be 1 over 3 times negative 6. 1 over 3 centroid times negative 6, because it is in the negative direction. This times x bar is equal to summation of area. Summation of area, it will be 6 times 6 plus 6 times 6 plus 6 times 6 plus 6 times 6 times half. Sorry, moment of area, I made mistake, sorry. This is moment of area is equal to total area times x bar. Sorry, I made mistake. This moment of area is equal to summation of area times x bar, because I want to find centroid in the x direction. So first I will take moment of area respect to y-axis. This is moment of area is equal to total area times x bar. From here I will find x bar is equal to 0.57 inch. Let's find in the y direction, y bar. In that case, I will take moment of area respect to y-axis. So it will be, for rectangular number 1, it will be 6 times 6 times 3, plus for rectangular number 2, it will be 6 times 6 times the distance of centroid up to x, it will be negative 3, plus for rectangular number 3 will be 6 times 6 times the distance of centroid up to x, it will be again -3 plus area for triangle number 4 1/2 times 6 times 6 times the centroid up to x, it will be 1/3 times 6. This is moment of area is equal to total area, which is 6 times 6 plus 6 times 6 plus 6 times 6 plus 1/2 times 6 times 6 total area times y bar. From here you can find y bar is equal to -0.57 inch. Okay, let's look at to the next example. Next one, it is very simple, it is T section. 120, 240, 240, 240, 120. All millimeter. Okay, I want to find y bar because x bar it will be on the symmetry axis, so it will be here. So x bar, if I put coordinate in the middle respect to this x and y, x bar will be at x is equal to 0. It will be at symmetry axis. But y bar I should take moment of area respect to x-axis. So I will divide to two rectangular. One rectangular is this rectangular, another one is this one. So let's take moment of area. For rectangular one, it will be area for rectangular one, which is 240 times 120 times the centroid of this up to x. It will be 240/2 or 120. So the area for this rectangular, it will be 120 times 240 times the center of this up to x. It will be 240/2, it will be 120 plus moment of area for rectangular number 2, it will be 120 times, this will be 480, this will be 600 if I add together, because this 240 plus 240 will be 480, 480 plus 120, it will be 600. So it will be 120 times 600 times the distance of centroid of this rectangular up to x. It will be here. It will be 120/2, it means 60 plus 240. 60 from here, 240 is this height. So 60 plus 240, it will be 300. This will be moment of area for T section respect to x. That is equal to summation of area. It means 240 times 120 plus 120 times 600 times y bar. From here you can find y bar is equal to 249 millimeter. Okay, I review several examples. Thank you so much for watching this lecture. See you next session. Bye bye.